All right, so now we're going to talk about the concentration of solutions. This is a way that we numerically talk about how concentrated the solute is within a solution. So how much solute is actually dissolved within a solution. We're going to put a number to it. We're going to quantify it, and we're going to learn how to calculate that. There's actually a few different ways that we can talk quantitatively about the concentration. There's two ways that we're going to learn. So first of all, also just terminology. If we have a small amount of solute in our solution, we would consider that to be a dilute solution. And if we have a large amount, then we would consider it to be a concentrated solution. But again, what we're going to do is learn a way to put a number to that, to numerically quantify it. Okay, so first is the percent mass. So this is the mass of the solute divided by the mass of the solution times 100. And mass of the solution is both the solute and the solvent, right? So this is going to be a key part of how we calculate this. We're going to have the mass of the solute, and then we're going to have to add the solute and the solvent to get our denominator here. Multiply that by 100, that will give you your percent mass. Okay, so let's look at a few problems here. So first, 29.5 grams of magnesium chloride dissolved in 100 grams of water. So the first step is going to be take out our calculator. So we're going to have 29. So the percent mass is going to be equal to 29.5 grams. That's the mass of the solute divided by the mass of the solvent plus the solute, which would give you the total mass of the solution. So 29.5 plus 100.0, those are both grams. Paying attention to sig figs, I've kind of been doing it for a while, so I know what to look for in my addition problem. If you guys are not quite comfortable with sig figs, you might want to do it where you're lining it up at the decimal again. However, I can tell that my correct number of sig figs will be here, divided by 29.5, okay? Whoops. Because then I need to take this and multiply it by 100. All right, so punch that into my calculator. You get 22.7799. I'm going to first note that the grams actually cancel. So these percentages do not have any units associated with them. So this is going to have a percentage sign at the end, not any units. All right, and then sig figs, I have 3 in the top number and 4 in the bottom. So this should be 22.8%. All right, I'm going to skip number B. You can see how that's done in the lecture slides that you download. I do want to do part C just as another example. So percent mass. Notice that here the masses are given in milligrams. That's fine. As long as the masses match, it doesn't matter what their units are. If one was grams and one was milligrams, then I'd have to do a unit conversion. But since both of these are milligrams, I don't have to worry about it. I can just keep it as is. So 278 milligrams, that's the mass of the solute dissolved in 475 milligrams of water. Water is the solvent. So to get the solution, I need to take the 478 plus 475. These are milligrams. Again, adding up the bottom, you get 753 milligrams, and that has that last sig fig marked, and 278 milligrams times 100. Again, punch this into my calculator. I'm going to get 36.918. And then the milligrams cancel. So I'm just left with that percentage sign, no other units. And then sig figs, I have 3 on top and 3 on the bottom. So this is 36.9%. That would be my final answer. Okay. Now, how do we use this piece of information? So we can determine the mass of solute present in each of these solutions. And let's just say basically we're going to do this by taking the same equation, but now we're going to rearrange it. Okay, so if I want the mass, so now before we were solving for the mass of the percent mass rather. Now I'm given the percent mass, and what's missing is this mass of solute. So what I'm going to do is just rearrange my equation. I'm going to have to take the percent mass, divide it by 100, right? I'm going to move 100 over, and then multiply the whole thing by the mass of solution. And if I do that, that would give me the mass of solute. All right, so that's what we're going to do in these next examples. Okay, so 250.0 grams of solution, that's 11.8% sodium nitrate by mass. What is the mass of solute? So now I have 11.8 divided by 100 times the 250.0 grams of solution. Punch that into my calculator, and I am left with 29.5 units. These quantities over here don't have units, so I'm left with grams. And it actually already has the correct number of sig figs, so that's nice. So yes, 29.5 grams of solute, which would in this case be the sodium nitrate. Okay. I'm going to do B as well. So here we have 150.0 milligrams of solution. That is 5.44%. This is methanol by mass. So 5.44 divided by 100 times the 150.0. Now my units are milligrams, so make sure to pay attention to your units. I punch this into my calculator, I get 8.16. And again, these are units of milligrams methanol. Okay, the other way that we calculate concentration is what's called molarity, or the symbol is this big M here. Molarity is the moles of solute divided by liters of solution. So molarity is moles per liter. Okay. So how would we calculate this? So let's do part A. We have 0.223 moles of glucose in 1.50 liters of solution. This would be, again, big M is moles over liters. So we would take 0.223 moles of glucose divided by the 1.5 liters of glucose. Punch that into our calculator and we would get 0.1484666. Units, we have moles and liters. That doesn't cancel out. So we're left with moles over liters. This is the same thing as that big M. And then sig figs, I should have, so sig figs, I should have this. So this is 0.149 moles per liter. And again, instead of writing moles per liter, we can write just that big M, because that's what that big M means. All right, so this would be a 0.149 molar solution. Okay. So now if we look at part B, we have 50 grams of glucose in 2 liters of solution. But molarity is moles per liter. So the first thing we're going to have to do is convert from 50 grams to moles. How many moles are 50 grams of glucose? How would we do that? Hopefully we remember that this is using the molar mass. So we would have to, given the formula of glucose here, use our periodic table and calculate the molar mass. I'm going to just tell you that I calculated the molar mass for glucose, and that was 180.15588. Remember, for molar masses, you always keep all your digits so you don't incur any rounding errors. You only ever round at the last step of a problem. So if I have 50.0 grams, I'm going to convert that to moles by dividing by the molar mass of glucose. So 180.15588 grams is equal to 1 mole. And then I'm going, so that calculation will give me my moles of glucose. So I'll do that first. This would be 0.277. Punch this into my calculator is all I've done. 0.2775374. If I'm paying attention to units, I am indeed left with what I want, which is mole. Awesome. And now sig figs. I will note that I have 3 sig figs, but I'm not going to round yet because I'm not at the last step of my problem. So then I'm going to take this number of moles and divide it by the 2.00 liters. And what I'm left with is 0.138768. My units are moles and liters. Nothing gets to cancel out, right? So this is just moles per liter. And I should have 3 sig figs. So my final answer is 0.139 molar, right? Moles per liter, and that big M, molar, are the same. So that's my answer for part B. And likewise, in part C, I'm given grams of glucose. Given grams of glucose, so I'm going to have to convert that to moles, but I'm also given milliliters of solution, so I'm going to have to convert that to liters before I can do my problem. So first step is going to be figure out how many moles is 136. Whoops, 100. Let's see, black. 136 grams. So I'm going to divide by that molar mass. Remember, how do we know to divide by the molar mass instead of multiply? It's because I want my units to cancel out. So I need grams to cancel, so grams has to be on the bottom. So punch this into my calculator and I get 0.7549. And I'm left with units of moles, which is what I want. And now I want to divide this by the volume, but first thing I'm going to have to do is convert from 750.0 milliliters to liters. And remember, the way that I would do that is using that constants page. I kind of just know it off the top of my head, but we have 1,000 milliliters is 1 liter. So I could actually punch that all into my calculator as it is, as long as I make sure to put that part on the bottom in parentheses, and I would get 1.00653 moles, and then moles, oh whoops, moles don't cancel, moles there. Milliliters will cancel with milliliters, and so I'm left with liters on the bottom. And then this is the same as paying attention to my sig figs, 1.01 molar. Okay, so that's how we would calculate the concentration of these solutions in molarity, starting either with moles of solute, that's easy, or if you're given grams of solute, you have to convert to moles using the molar mass. Okay, so now we're going to use our molarities. So now, given the molarity, determine the volume that contains a certain number of moles. So for each one of these, what we're going to do first is take, for example, this piece of information here and make it into a conversion factor. So remember that big M is moles per liter. Whoops. That means that 1.0448 big M is the same thing as saying that there are 0.0448 moles in 1 liter of solution. So this is going to be a conversion factor that we're going to use to convert from moles to liters or liters to moles. In this case, we want to know how many liters are 3.1, how many liters are needed to contain 3.13 moles. So we're going to start out with 0.313 moles. So then I'm going to take my conversion factor here, and am I going to use it as it is, or am I going to have to flip it upside down? Right, so I need moles to cancel, so I'm going to put that 0.0448 moles on the bottom and 1 liter on the top. So I punch that into my, so I punch that into my calculator and I get 6.9866. I have to move quick. My units, moles will cancel out, and so I'm left with liters. And then I have 3 sig figs in this problem. So this would be 6.99 liters. That's how much of that solution I would need to have 0.313 moles of solute. All right, we'll just do the other one. Let's just do B. So here I have my same sort of idea. I'm going to take this and make it into a conversion factor. It's for the same number of moles. That's what the problem states. So I'm going to start out with the 0.313 moles. But now my conversion factor that I'm going to use is going to come from this piece of information here. And again, I want moles to be on the bottom. So this is 0.105 moles in 1 liter. Punch that into my calculator, and I get 2.98095. Again, paying attention to units, moles cancel, and I'm left with just liters. So that means 3 sig figs in 2.98 liters of this solution. That's how much I would need to get to 0.313 moles of solute. Okay. Well,